Hello everyone, this is a video lecture for College Algebra, Math 1314, Section 4.4, Logarithmic Equations. We're going to be solving for x. So, first off, solve for x. Every single one of these questions is solve for x. There's a strategy to all these, and I would like to just show you as we go, but there's not any one explicit formula. I can't just say, well, here's your formula. I would say this is more like a strategy, and if you see that this way, do it. If you see it a different way, do it some other way. That's just what I recommend. So 3, can I get a 3 over here? I think so. Is there a way to get a 3 over there? 3 to the something power. 3, 9, 27, 81, so it's the 4th power. Well, now 3 to this is equal to 3 to that. You can cancel your 3's. The point, what I'm trying to say is that there might be some easy way to solve if you just cancel on both sides. And indeed, a lot of the first problems are going to be that way. Divide by the 4, x equals 2. There you go. Next problem. Similar thing, if I can get a 3 over here, I think we're going to be looking really good. So I think that that's going to be 3 cubed in the bottom, but because it's in the denominator, you have to flip it up to the numerator and make its power negative. At this point, you can cancel those guys. Start solving for x. I'm going to add x to both sides. That's maybe not conventional, but that's what I do here. Add the 3 to both sides. So x is equal to 5. Cool. Another one. Can I get a 5 on both sides? Yeah, for sure. That's 5 to the 1/2 power. Cancel your 5's. Not every problem in this section is going to be this easy. I'm just wanting to show you that there are easy ones. So basically here, if I make the 8 come over to this side, I'm going to get a 4. So I get a 4 there. Add 9 to both sides. 13. Cool. Next one. Can I get an e on both sides? Yes, again, you can. That's technically e to the negative 1. It's the fraction. You flip it, make a negative power. Cancel your e's out. Minus 5 on both sides. Negative 6. All right. Can I get an e on both sides? No. But I think it's kind of obvious. And so we're going to have to change our strategy here. I'm going to just tell you that you could always do friends. That's the technique we've used a while ago in other sections. You can move it around, and I'll show you that right quick, actually. So because I got a base e, this is now log base e, something and something else. E and x were good friends, no longer. See you later. 8 was all by himself, and now he's got a friend with the e. Log base e can be rewritten as ln. And so did you just solve for x? Yeah, actually you did. I don't recommend this right now going forward because we're going to be doing a lot more than just this. So I want to teach you a strategy that will be basically the same thing here, but later on it'll be easier to use as we keep going, okay? They're going to want a decimal equivalent. So that's actually just a part A. Part B, decimal equivalent. And so you just go to your calculator, type ln, 8.73, and I got 2.1667 for this guy. Okay. So what's the other way to do this? Well, so I have my equation, and I see an e, and I'm going to ln both sides. Here, I'll write that down. ln both sides. And so e and ln cancel, and there you go. Without any kind of flipping things around or friends or whatever, you got the same answer immediately. So ln both sides. I think that this will not just make it faster, but it'll make it more accurate as we keep going with other problems that may not necessarily look so easy. So I want to ln both sides. I see that we got an e, and I can't get an e on this other side, so what do? We'll ln both sides. But there is something I need to do first. I need to divide by the 5 first. And what that's going to do is simplify this down a lot. And so I'm just telling you, because this particular problem has gotten me in the past, and if it can get me, then it can get you, I suppose, as well. Divide by the 5 first. We'll do the ln later. That's fine. But divide by the 5 first. And now, ln both sides. And so we got 5x is equal to ln of the 673. Solve for x. I'm going to divide by 5. Watch out here. Watch out. There it is. You're done. Do not combine that 5 with the number on the inside. Just leave it alone. Leave this number alone. Leave alone. Locked in. I don't know. Whatever you want to call this thing. Just do not change that number. Once it's inside an ln, it's done. Don't do anything else. And they want the decimal equivalent. I'm just typing this in my calculator. I got 1.30234. Cool. Keep going. So, can I get a 7 on both sides? I mean, that's really honestly what I would be thinking. So, 2255 divided by 7. There's no 7s in there. It doesn't work. So, what I want to do is, I can't get a 7 over here. What can I do? Well, you can ln both sides. Oh, I know, you can do friends and many other things. But I'm going to choose to do ln of both sides for a very specific reason. Now, they don't cancel. But you could bring this down as a power to the front. And then I'm going to divide both sides by the ln of 7. You don't need parentheses over here anymore. This is a lot of steps. Again, though, there are quicker ways. I'll show you why not to do them in just a second, okay? And so my final answer here is going to be ln of the 2255 all over ln of the 7, and all minus 3. These don't combine. This doesn't combine. Just leave it alone. And then you're done. I need to find a decimal equivalent. While I'm doing that, I'll tell you why. So the homework program is very picky about these problems. And what they're wanting is your exact answer in terms of natural logarithms. I'm not going to write all that down. That would be way too much for me to write. They want, again, a part A and a part B. They want their exact answer using natural logarithms. They're saying use ln's. Put ln's in there. So if you're going and putting log base 7, 2255 minus 3, which is a completely correct answer. That's a completely correct answer. They're not going to like it because they want it in terms of ln's. Okay, so they're going to say, no, it's not right. You need to do this. So that's why I'm showing you ln both sides. That's how you're going to get through this homework. And thus the homework, also the quiz, and also the quiz, also the exam. All right. Now, I can't ln both sides if I've already got a log. And, I mean, we could do a couple techniques, but I'm going to just choose my favorite. It's friends. So I got my base of 2. I got something up top and something on the side. 2 and x plus 14 were good friends. No longer. You're out of here. 3 was all by himself. Now he's got a friend with a 2. Well, 2 cubed is 8. And then we don't need the parentheses over here. Minus the 14 on both sides. And so we get x is equal to, I'm just going to verify. It's like 6, I'm sure. Yep, negative 6. Okay. Good. That was it. Not too bad. So friends, that's a good technique once in a while. Okay, what about this guy? Well, first off, I'm going to minus the 4 on both sides. So I got 14 ln x is equal to negative 2. I'm going to divide by the 14 on both sides. And so then I got ln of x is equal to negative 1/7, I guess. To get rid of this ln, what you need to do is e both sides. It's kind of like the opposite of ln both sides. So you e both sides, kind of like that. Cancel. And so x is equal to e to the power of negative 1/7. Again, you can find your decimal with that kind of stuff, but I'm not too concerned at this point. So e both sides, ln both sides, whatever you need to do. You can do friends. That'll also work here. Okay. So we got logarithms, and we need to solve for all this stuff all together. This one's a little different than the other ones because I got two of them. Well, notice that there's a plus sign between them, so that means that you're going to have a multiply on the inside. And this is the log base 8, so you got x times the 7x minus 1. Okay, cool. So there's a few ways we can go about doing this. I'm going to simplify the inside first. 7x squared minus x. And now I'm going to do my friends. 8 up top on the side. 8 and all these x's were good friends, but no longer. And then I got 1 by himself. Now he's got a friend with the 8. So 8 is equal to 7x squared minus x. And I need to solve for x. I'm going to minus 8 on both sides. It's like we're going to have to do a whole other problem here. So I need to solve for x here. There is definitely a lot of ways to do this, but I'm going to factor. I know that's very strange because the 7 in the front and all this stuff, but 7 is prime, and so you're definitely going to get a 7. Also, notice the 8, and so 8 could be 8 and 1, and 2 and 4. I'm going to choose 8 and 1, but I'm going to choose the 8 right here and a 1 right here. I'll show you why in just a second when we start double checking ourselves. As far as negative and positive is concerned, we're going to have a negative 1 add up to a negative 1. And so if I had a positive 7 and a negative 8, it should work. So that's my factored version. Let me just verify. So here we go. I've got 7 times x is 7x squared. I've got 7 times the 1 is a positive 7x. I got negative 8 times x is negative 8x, and then I got a negative 8. When you combine like terms, you indeed get what we had originally. So that's good. It means we did it right. If you want to use another method to factor, that is okay. I'm just wanting to get it done with because we've had a lot of factoring already. I just wanted to show you, factor this guy, this is what it looks like. So we need to take these factors and still solve for x. And so what we do is we now take them individually and set them individually equal to 0. So 7x minus 8 equals 0. Add the 8 to both sides. Divide by the 7. 8 sevenths. Over here, though, I just say it's negative 1. Not too hard. And so those are my two answers that I would have to put into the homework program. The problem is that it's wrong. Yep, it's wrong. What we actually have as the only answer is this one here. This one's not the answer. And why is that? Well, I have to go back to the very first original statement. So log x, and then the 7 minus 1. So log base 8x. That was a plus sign. Log base 8 of 7x minus 1 is equal to 1, I believe. Yeah, okay, yeah. Just making sure. So what if I plugged in to x my negative 1? Let's just start with that. Well, now I've got log of negative 1, which does not work on a calculator. It'll just error. So that's no good. Okay, but what if I try plugging in the 8 sevenths? If I plug in the 8 sevenths into both of those, that one checks out. Here we got log of 7 times 8 sevenths minus 1. The sevenths cancel. 8 minus 1 is 7. Log 7. Yeah, that's fine. That's fine. So everything's fine. And that's the only one that works. Okay? So that's it. You just, like, hey, what do I type in my answer? 8 sevenths. That's it. All right, cool. Let's do another one. So here's another log equation. Again, I have a minus sign between them, so I know I can combine these with a division. Yep, that's right. Just going back to those properties of logs. I'm going to use my friends, so I got my base 6, 2, and then a big fraction. Eventually, you just kind of know the pattern, and you don't have to keep saying it, but it's up to you. So 6 squared is 36. Now I'm going to multiply that here to the other side. Actually, I want to bring it up a little higher than that. So I got 36 times x minus 11 is equal to x plus 24. Distribute your 36. 36x minus, that's something I'm going to need help with. 396. Hopefully I'm going to get this right. I'm going to minus x on both sides. And I'm also going to add the 396 to both sides. So that's going to be 35x is equal to, I'm going to add 24 to that thing. And I got 420. Divide that by 35, and yeah, it works. Awesome. I get 12. Now, do I have to double check this number? Like I double check the last problem, but why not this problem here? I mean, it just works, right? Well, there's two reasons. First off, if you've got two answers, like what we had, two answers, you should double check. Here, two answers, you should double check. You should do it twice. You only have to do this a couple of times. My point is that if you got two answers, double check yourself generally, okay? And generally, negatives don't work. Generally. I'm not going to say always. That's a general one. Well, here I only got the one answer, so I'm pretty much good to go. It's also not negative. I mean, negatives work sometimes, but I would just be more cautious with a negative. All right. Another one. So what I want to do eventually, not first. If you do this right first, you're wrong. Don't do that. No, 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 no. Everyone does that. I don't want that to happen to you either, okay? What you want to do first is combine these with the plus sign. And I'll show you why people do that here in just a second, okay? Just give me a second here. So a plus on the outside is a multiply on the inside, which is good. But now you can cancel your ln's. So you are canceling, but you're not canceling step one. Most people, getting this wrong, would cancel ln's here and they get some weird answer. That's totally not right. Don't do that. Yes, you will cancel, but not first. Combine like terms, all that kind of stuff. We're just simplifying a little bit here. So x squared minus the 4x plus 4 is equal to 0. We can factor that. Should be a negative 2. Negative 2? Yep. And so if you set each one equal to 0, x equals 2. Now, I've got two answers. Technically, I got two answers. So I should probably double check myself. I know I don't have a negative, but this is kind of weird. Two answers, double check, right? Well, if you plug a 2 in right here, you get ln of negative 3. That's no good. You can't do that. So that one doesn't work. Hey, let's plug in a 2 and see what happens. Oh yeah, it doesn't work. I don't have any answers. So how do I put this in to the homework program, you know? What do I say? Well, there's no solution, honestly. So you would click no solution and keep on moving. There's nothing to talk about there. Okay, number 13, another one. There's a lot of them in this section. So I'm going to combine like terms. I don't want to say combine like terms. Combine these two together with the division. And then also here, combine these with division. And now, yes, cancel your ln's. You knew that would happen at some point. Just don't do it step one. Move this around, move this over here. So at least now we don't have division, though it does look pretty intimidating. When you start to FOIL these out, here I'm going to get a positive 4x minus a 21. Over here it's x squared plus a 2x minus an 8. You know what's funny about this problem? This is actually pretty cool. Minus x squared on both sides, and they cancel. This is a good thing. This makes this problem a lot easier than it seems. So I'm going to minus the 2x on both sides. I'm going to add the 21 to both sides. And so what we have now is a 2x is equal to 21 minus 8. Again, I'm just verifying about this stuff. 13. Divide by the 2 on both sides. 13 over 2. There you go. Some answers are fractions. That's fine. It's just part of it. Unless I messed up, of course. That is a possibility, but I did not. I'm checking my work, and we're good to go. So, yay! All right, awesome. Let's keep going. So it says that we have this formula for the population, and T is years after 2000. So when will the population be this much? Now, there's a second part to this problem, but you're basically just plugging into T equals 0, but it's not even worth our time. This part is our answer, not T. It's our answer. And so what I need to do is solve for T given this equation now. We're going to use the same techniques that we've already been learning, but I want to show you, I guess, a little bit more straightforward answer here. It's called divide, ln, divide. Okay, so first off, I'm going to divide by the 19.6. And I'm going to keep these decimals all together for a little bit because I don't want rounding errors. Okay, to get rid of that E, I'm going to ln both sides. So you ln both sides, so you divide, ln. So a lot of work here. I actually am trying to do most of the homework problems with you here because, well, there's a lot, and I feel that every one of them is a good problem that we should talk about. Last step, divide. So I'm going to take this division right there and divide it. Well, I'm going to take that multiply and I'm going to divide it to the other side. I think one of the hardest parts here is just rewriting all of the math when you just have to do one simple step. You do not need to rewrite the entire equation every time. I'm just showing you. But when you're doing this math, do what is comfortable for you. Honestly, for me, I'm more comfortable with skipping a step here and there. But I'm not comfortable with just skipping the entire thing because then I don't know what I did wrong at the very end. So that's basically our answer. Now, of course, we need to find that decimal equivalent. They are talking years here, like when did this happen kind of thing. So let's start typing that in. ln 25.9 divided by the 19.6, close parentheses, and then divide again by the 0.137, and I got 20.34. Okay, now these are years, 20.34 years, okay? So when will the population be this? 20.34. Okay, round it to just 20. It's not 20 AD, okay? Remember, it started in 2000, and so it's 2020 AD. That's what they're wanting. Again, yes, round, of course, but you're needing to make sure to use the year, okay? They don't say AD, so you just have to know it, okay? All right. I think this is my last question. Yeah, this is my last question, but there are other ones on the homework. I just chose to make this one my last question because the rest of them are, even if they are like application style and word problems, they're not any harder. They're all the same as what we've been doing. Anyways, the one goes right here into f of x. And so it's literally tempted to say like 1% should be like, 0.01 and all that stuff, but that is not how they're rolling in this problem. There's talk about sunlight and how much percentage of sunlight gets down to the bottom of the ocean, something like that. Just put a 1 there. Just put a 1 there. And so this, to solve for this, is a tiny bit different than the others. I'm going to divide by the 24 on both sides. And I am going to ln both sides. I am. But you can see that what's going to happen is that my ln is not going to cancel. But that is the appropriate step. It's still divide, ln, divide. But we're not really kind of dividing anymore here. I mean, yeah, we are. It's just not the same, because the x now, as a power, comes to the front. And then, instead of canceling, and then I finally divide. So it is a divide, ln, divide situation. But still very different. It's still very different. So I wouldn't just count it as the same thing. It's definitely a whole different problem here. Put all that in the calculator. ln 1 divided by 24. Then divide all that by ln 0.985. And on the cursor, 210.2772. Now, the answer that the homework program wants for part A is 210. I'm looking right at it right now. This is what they want. It's like in feet or something like that. That's cool. But part B is strange. It says, now represent this on the graph. They want an x, y coordinate point. And so what you're actually going to do, because that was x, right? So x was the 210 and y was the 1. This is what they want for part B. You got to put it in that format. The other problems that I have here are investment problems, and then there's a bar chart, and then there's another one very similar to this. All in all, not too bad, and I know that you can do it. So that's all I got. Thank you very much, and have a great day.